Hello students, today we will start a new topic, that is gas chromatography. Gas chromatography is a type of gas liquid chromatography. That means के the mobile phase is gas and the stationary phase is liquid. In most cases, maybe gas chromatography may be the stationary phase may be solid. In that case, that is known as gas solid chromatography, and the stationary phase may be liquid. In that case, it is known as gas liquid chromatography. But if we use the term gas chromatography, that means it is a gas liquid chromatography and the stationary phase is liquid. It is also a high efficiency method of chromatography, and in gas chromatography the gas chromatography is used only for that analytes which are volatile in nature and which are thermally stable compounds, maybe organic compound, maybe inorganic compounds. And the mobile phase, as I said, the mobile phase is gas, and the gas should be non-reactive or inert gas. It should not interact with the analytes, so it acts only as a carrier. It should not interact with the analytes. So the gas is non-reactive and maybe inert gas. In both cases, if it may be inert or it may be non-reactive. For example, the gases used are nitrogen, helium or argon. In most cases, helium is used as mobile phase, which is an inert gas, and the stationary phase is liquid, and mostly it is maybe silicon wax, maybe a carbo wax, polyethylene glycol, so on. Different type of liquid stationary phase are used. One of them is silicon wax or carbo wax, polyethylene glycol. The solvent used for analyte is either acetone, hexane or methanol. These are the solvent used for analyte. That means analyte should be volatile, solvent should be acetone, heptane or methanol, mobile phase should be non-reactive or inert gas, that is nitrogen, helium or argon. Support is silica, it is inert structure. And the column used, chromatography, gas chromatography is a column chromatography. The column used, both type of column is used, packed column and open tubular column, that is capillary column. But both cases, open tubular column used. In open tubular column, two types of column is used, that is wall coated and support coated. Wall coated means the stationary phase is coated directly on the inner surface of the wall of the column, and in the support coated, the stationary phase is coated on a support present on the inner surface of the wall of the column. That means first, this is the inner surface of the wall, here a support is coated, and over that the stationary phase is coated, that is support coated. And in this case, on the stationary phase is directly coated on the inner surface of the wall of column. These are the some components used in the gas chromatography, and this is the apparatus used in the gas chromatography. This is the column. The column is about 25 to 30, 50 up to 50 meter long column. This column is made of either steel or it may be made of quartz depending upon the type of analyte or column is used. So this may be made of stainless steel or may be made of quartz. It is a coiled structure, long coiled structure, and the whole column is present in an oven, and the temperature of the oven is maintained between 50 degrees Celsius to 30 degrees Celsius. That means whatever the temperature of the oven is the temperature of the column, because the column is present in the oven, and the temperature of the oven is controlled by a regulator that is known as temperature programmer. That means during the process, temperature of the oven can gradually increased or to increase the rate of flow. Generally, rate of flow in the column is directly proportional to the temperature of the column. That means higher is the temperature of the column, faster is the rate of flow. Generally, rate of flow is 40 to 80 cubic centimeter per minute. This is the structure of oven containing the column. Here is a sample injector through which a known quantity of sample is injected, into the column, and this is the gas supply containing the inert or non-reactive gas. This gas supply passes through the injector, and it carries the sample into the column. The supply of gas should be continuous. A known supply, known flow, known pressure of gas is supplied. It should be continuous. It should be continuous. It should not be interrupted. Continuous supply at a precise pressure. The gas is flown into the column, taking the sample, which is injected through this injector. The column, when the analyte along with the gases passes through the column, its rate of flow is different. The rate of flow depends upon its interaction with the stationary phase. More is the interaction, less is the rate of flow, and that also depends upon the temperature of the column. So in the column, different type of substance flows with a different rate, resulting in their separation. In one more thing, this is the injector point. The temperature of the injector point is always somewhat higher, about 20 degrees Celsius higher than the rest of the column, temperature of the column, because higher is the temperature, more quickly the substance gets vaporized or converts into gases. So this contains a higher temperature. This converts the solvent analyte, the analyte present in the solution to vaporize quickly, converts into gas, and that gas flows through this column with a differential rate. It passes into this is the inlet point, this is the outlet point. When the substance passes out, it passes through a detector. Detector detects what type of compound is present, and that information is given to a recorder or data system which forms a graph. The graph contains, this is the intensity and this is the time. One more thing, the detector, various type of detector are used. It may be a flame ionization detector, it may be a thermal conductivity detector, it may be a mass spectrometer. Mass spectrometer also also measure the mass of the solvent, mass of the analyte coming out, passing through this detector. Okay, so this is the method in which, suppose this is the part of the column here. That means if some of the substances are here, this will pass this, and these are another analyte. This one is another analyte and this one is another. Rate of flow is in this direction. Here those substances which have a higher boiling point will move slower than those substances, those analytes which have a lower boiling point. That means a substance having lower boiling point will move faster than those which have a higher boiling point. Similarly, substances having a larger size will move slower than the substance having a smaller size. Those analytes which have a smaller size or have a lower boiling point will move faster through the column, and those analytes which have a higher boiling point or larger size will move slower in the column. As a result, different analyte moves through different speeds or velocity. This differential speed or velocity leads to their separation and their identification in the detector. That identification information is passed through to the recorder or data system, and data system forms a graph. That means this graph, earlier we have discussed this graph also in the HPCL, in the HPLC, that is the high performance liquid chromatography. That means this is the graph, this is the intensity, and this is the retention time. Retention time means how long an analyte is present or stays in the column, how long it stays in the column. That is the retention time, or how long the column retains that substance into it. This is the retention time. So this graph, the first graph which is formed, is of those which have a lower boiling point or a smaller size, and those, the second graph represent for the analyte which have a higher boiling point or a larger size. That means if these type of substance are present, when the substance passes through this, the temperature of the oven is gradually increased to increase the movement of this substance also. So this is the process, and this graph when formed, the area present in the peak gives the information of the quantity of the substance present, and this peak identify this retention time gives the information about the quality of the analyte, and the area gives the information about the quantity of the analyte. And these information are present in the data system also. So this also helps in the identification of the substances, and this particularly this mass spectrometer also aids in the identification of the substance by analyzing the mass of the analytes passing through the detector. That means that through this process, a volatile substance is identified in the process through the gas chromatography. Through the gas chromatography, when it is frequently is in the used in the forensic laboratory. It is used in various industry for the identification or quantification of the toxic substances present in the air or water or soil. These are just to identify the substance present, particularly the toxic substances present in the air, water or soil, or the toxic substances present in a product or in the forensic laboratory also. So this is the application of the gas chromatography. The first important thing is the gas chromatography. The solute, the analyte moves in the gaseous state. That means it should be volatile in nature, but it should not change its nature when heated up. So it should be thermally stable, but it should be volatile. That means it moves in a gaseous state, and different gaseous molecules or different analyte molecule when interact differently with the stationary phase, resulting in their separation through the column, and these separated analytes are identified by this detector, and the data is presented in the data system. That is all about the gas chromatography. Hope you have enjoyed the lecture. Thank you very much.